Welcome back everyone. Today we learn about pressure. Pressure is defined as the force exerted per unit area. It can be defined by using this formula, P equals F over A. The SI unit of pressure is Pascal or Newton per meter squared. There are two ways to increase pressure: either we increase the force or decrease the area the force it is applied on. Examples included using knives with small areas to cut objects and skates with small blade areas that exert pressure, and melt ice to facilitate skating. To reduce pressure, we can either reduce the force applied or increase the area on which the force is applied. One example is using tracks of a large area for dozers to move on soft ground like dirt. Let us use an example. The diagram shows a block on a slope. To find the pressure exerted on the slope, we have to find the force exerted by the block on the slope. Using trigonometry, we can use mg cosine theta as the force applied. We use the force perpendicular to the slope as it is the amount of force that is being applied on the slope. We also use the surface area of the brick, A, that is in contact with the slope. This further allows us to find out the pressure exerted by the brick on the slope. Let us talk about liquid pressure. A liquid exerts pressure due to its weight. Pressure is dependent on the depth of water, liquid density, and gravitational strength on Earth. On the diagram, we can see that as we go deeper, the pressure exerted on the water increases, and the distance the water shoots out increases. Also, pressure acts equally in all directions in the same depth. By using the formula, we can substitute pressure with the weight of the liquid. This gives us mg over A. Taking ρ as the density of the liquid, we can further evaluate it as V rho g over A. Hence, we can say that the pressure is the product of liquid density, depth, and the gravitational field strength. Here is an interesting fact: an object floating in water experiences upthrust, which is the overall upward force exerted on an object in liquid. Here is a derivation of the equation for upthrust. The derivation is based on the force Fb exerted vertically on the bottom of the cube due to pressure subtract from the force Fa exerted vertically downward on the top of the cube due to pressure. A is the area of the face of the cube. Hence xa is equal to the volume of the cube and represented by V. The diagram below shows a hydraulic press, which involves a tube containing two pistons. In between the piston, it contains an incompressible fluid. In a hydraulic piston, the pressure exerted on the fluid at A2 is equal to the pressure exerted at A1. Hence a downward force exerted at piston 1 will produce a large upward force at piston 2 since the area of piston 1 is smaller than piston 2. Let us talk about some uses. Hydraulic pressure can be used in garages to lift vehicles, to repair parts under the vehicle. They are also used in braking vehicles whereby stepping the brake pedal introduces pressure to 4 other pistons which apply discs or brake shoes to the car wheels. Here is an example of it being shown. How does a car brake work? Force is applied at the braking pedal, creating a force that is applied to the master piston. The master piston then exerts pressure on the fluid. Hydraulic pressure is transmitted through incompressible brake fluid. As a result, pressure is exerted at the slave piston. Next, let us talk about atmospheric pressure. Atmospheric pressure is the pressure exerted by the weight of the atmosphere. How strong is it? Atmospheric pressure at sea level is 10 to the power of 5 pascals or 1 bar. As the altitude increases, the pressure will fall. Air pressure is very strong such that when you remove air from a can, the can will be compressed. To measure atmospheric pressure, we use an instrument known as a barometer. Here is a diagram as shown. How do we make one? Firstly, we fill a glass test tube with mercury. Next, we invert it a couple of times to expel the air bubbles in the mercury column. Lastly, we expose the glass test tube under a trough of mercury. When we use a barometer, 760 mm Hg of mercury can be seen. we use mmHg to measure atmospheric pressure in a barometer. 760 mm Hg is the pressure exerted by the atmosphere. Even if we tilt the tube, the 760 mm height is still maintained. I wonder. Which of the following will not change the height in the barometer? Lifting the test tube higher with the mouth of the test tube still submerged in the mercury. Add more mercury to the basin of mercury. Bring the mercury barometer to a higher altitude. Slanting the test tube. Adding air bubbles into the vacuum from the tip of the test tube. The actions circled in red do not change the height. This is because the variables that are changed did not cause a change in the atmospheric pressure or the pressure in the barometer. As we increase the altitude, atmospheric pressure that exerts pressure onto the mercury drops. Thus, the height in the barometer falls. What about adding a few air bubbles into the vacuum at the tip of the test tube? Atmospheric pressure exerted on the trough of mercury is negated by pressure in the air pockets in the tube. Thus, height in the barometer decreases. Another way to measure gas pressure is with a manometer. It can be filled with any type of liquid such as mercury, water, and so on. In this scenario, when both levels in either end of the manometer are of the same height filled with the same liquid, the pressure exerted by gas A and gas B are both the same. But what if it shows both ends having different height? The diagram below shows gas A exerting a larger pressure than gas B. Hence, we can also say that pressure A can be found by adding pressure by gas B and the difference in gas pressure. The difference in gas pressures can be replaced with h rho g, where h refers to the difference in height levels. Here is another scenario where gas A exerts a smaller pressure than gas B. Similarly, we can also say that the pressure exerted by gas A is the pressure exerted by gas B minus the difference in gas pressures. Let us look at an example. If pressure A is the atmospheric pressure and the difference in height is 20 mm, what is the pressure exerted by B? We can state that the pressure by gas B is the atmospheric pressure plus the difference in pressure between A and B, which is 20 mmHg. This should give us 780 mm Hg. This is only true if the mercury is the liquid in the manometer. Let us try another one. Here we see the same manometer, but with points at C, D and E. The pressure at D is at atmospheric pressure. Given the density of mercury is 13,500 kg m3 and H equals 10 mm, what is the pressure at C and E in pascals? At the start, it is important to note that pressure at C is equal to pressure at E since they are at the same height. Thus, the pressure at C is higher than pressure at D, and is equal to pressure at D plus h rho g. For this question, pressure is to be expressed in Pascal instead of mmHg. To do that, we have to substitute h to be 0.01 meters, rho is 13,500 kilograms per meter cube, and g is 10 meters per second square. How about at point E? The pressure at point E and the pressure at point C are the same. Despite being in different ends, the level at which point C and E are the same. Hence, the pressure of E is also 101,350 pascals. That's all for today. Thank you for the effort to learn with me. Stay tuned for more interesting lessons. See you next time. Bye-bye.